Hi dear students, today we will discuss the next problem. The first of all, read the problem. The following data pertains to a tension test conducted in laboratory. Diameter of the specimen is 15 mm. Length of the specimen is 200 mm. Extension under load of 10 kN is equal to 0.035 mm. Load at the yield point is 110 kN. Maximum load is 190 kN. Length of the specimen after failure is 250 mm. Neck diameter is 12.25 mm. Determine Young's modulus, yield stress, ultimate stress, elongation, percentage reduction in area, safe stress, adopting factor of safety of 1.5. So it is one of the very important problem, you can say. It will ask for 10 marks. So let's, this problem you already studied or you want to study in the lab, empty lab, mechanical testing lab. Let's we'll have the diameter this one. What is this problem? As I told in the last class, one problem we already discussed in the tensile test. So this is the specimen used for testing tensile test. So length of the specimen, after failure they are given. So you need to determine length of the specimen. They are given 200 mm. They are given here 200 mm. In the problem they are given here. Length of specimen is 200 mm. Diameter is 15 mm. So this is the diameter of the specimen. So the specimen is usually like this. The specimen is usually like this. Middle it is having a neck. So here what they will do, they will apply the tensile force. I'll put an animated video on this so that you'll understand clearly. Here what are the things you need to calculate. You need to write all the data first. What all the data they are given. D is 15 mm, length of the bar is 200 mm, load applied is 10 kilonewton is equal to, you have to always convert kilo into Newton. Kilo means 10 raised to 3. 1 kilo is equal to 1000 gram. So 10 raised to 3, 10 into 10 raised to 3 Newton. And the extension of the extension load is 0.035. Means when we extending this bar, what will happen? This 200 mm will, this bar will stretch because of the load is applied here. So it becomes 200 point, what is extension 0.035. 200.035 is the after extension of the rod will take place. It will stretch. Now what is the final length they are given? 250 mm. Means after the this one extension of the rod or failure, after the failure of the bar, it will fail like this, and when they join together, so the length of the bar is, it is cut, it's going to break here when you apply the maximum load. So then it becomes a 255 mm. Okay, final length. Neck diameter is 12.25 mm. So write this all the data properly. You study this problem. Once again I'll send this in a PDF format. Young's modulus E is equal to stress upon strain. So this you can write, it is a stress upon strain. Stress, you can use both the symbols, sigma P by A. So 10 into 10 raised to 3. So this is what load, pi by 4 into d square is the area. So here you are calculating the stress. Here you are calculating the stress. Then after calculating the stress, you need to calculate the, what is this formula? Strain. Small e is equal to dl upon L. dl is what? Change in length. L is original length. So you will going to get change in strain you will going to get. So what is the formula of Young's modulus? Stress upon strain. I'll write like this: stress upon strain. E is equal to stress upon strain, because we're using the notation sigma. So sigma already you calculated. You have got the stress, that is sigma is equal to 56.58 Newton per mm square. You already calculated. So 56.58 you have to take here. Here you are going to get the Young's modulus, stress upon strain. You got both value, stress value, strain value divided by that. You always put the bracket while calculating, so you will get the same answer. Then yield stress. What is the yield stress? Yield load upon cross sectional area. This I already explained you while explaining the curve. So when you are applying the load, it will be under, so within elastic limit, it is called proportional limit, and as you goes on increasing, the elastic, it goes beyond the plastic limit, then it goes slight curve, it will ultimate load will takes place, then finally breaking will happen. This is the stress upon strain curve. Okay, so yield load upon cross sectional area, so you are going to get this answer. Then ultimate load upon area, here it is, ultimate load upon area, so you got the answer. Then percentage elongation. What is the percentage elongation? Final length minus original length divided by original length. This all data are given in the given data. You need to check. Just now I said final length is 255 mm. So where I explained you already here, 255 mm. Then do put here 255 mm final length minus 200 mm divided by 200. So you will get the percentage. So like this you have to calculate the percentage elongation. Then next comes percentage reduction in area can be calculated. Use the formula. What is that? Original area minus area at failure divided by original area. What is the area formula? 5 by 4 into t square minus 5 by 4 into df square. So it is the original, that's what is written, only d, and it is final, that's why it is written df. Df means final diameter. Okay, then what will happen here? This pi by 4 they are taken common. What in this pi by 4 they are taken in the bracket, they left is d square minus df square. So this pi by 4, this pi by 4 get cancelled. It remains here what? D square minus df square divided by d square into 100. So you will going to get the answer 30.5 is the percentage reduction in area. Like this you need to calculate this problem. So I'll send another practice problem. You need to practice that problem. If not understanding, once again I'll do the video. Okay, thank you very much.